Okay, it's about a project, a research project for visibility analysis for the implementation of small urban wind turbines that I will explain just now. So this is a project with with two partners actually. It's a private company based in Brussels, Buildwind, and the team of architecture and climate of the research agency, research institute of the University of Louvain-la-Neuve in Belgium. And this project is co-funded by the Service Innovates of the Brussels Capital Region for research projects. And what was it about? It's a happy ending now. It's about identifying whether implementing wind turbines in the city is a feasible solution. So we set off to identify suitable locations for the wind energy harvesting inside Brussels and calculate the environmental benefits of these locations, which is something that depends both on the location and the wind turbine. And also as examine environmental effects, specifically the visual and the noise, so that they can be used for urban policy making process in case they are installed. So we have here a type of wind turbines which is actually a vertical axis, which are more suitable for the urban environment. It's called Savonius, and they is this type that's called the Darius, which is like a wing of an aeroplane. So the non-urban wind turbines have been examined extensively for their effects in the environment, but the urban environment is quite different, and this is a very different research. So many effects have been identified. Some of them are good, like the effect on air quality. Some of them can be bad, such as the noise or possible effect on the urban wildlife. Some of them might be unknown, like the possible effect on microclimate, and some could be either positive or negatives, like the visibility effect. But in other case, in any case, we need to have ways to quantify these effects and also examine them qualitatively in the second stage. So the urban wind is a very complex issue in comparison to the non-urban wind. So this is the part where the private company is working mostly with simulation. We have also tested the ArcGIS that has a plugin for wind simulation uh, available, but this was done just to test the specific software. And we know that this is not something that is not static, so it changes with as the city changes. So there's a result from this examination with the wind potential. You see the colors on the roofs that define different and wind energy potential. And then by selecting a specific model of wind turbine, they are placed on the optimal locations to exploit this wind energy potential, and then assessed, as I said, for their energy payback. So the ones that pay back in 3 years or 5 years are a good choice, but the ones that exceed 15 or 20 years are not a good choice because we spend more energy in creating them than the energy that they produce. So the viability is examined environmentally and not financially. So what we did on the effects part, a toolbox was created in ArcGIS Pro with tool commands to examine the visibility. So this is an approach mostly based on ArcGIS, and for some reasons that I will explain immediately after, the CityEngine got involved in some parts of this examination. The tool allows to start on the 2D environment and create observation points for the specific targets that we are aiming to examine, which is the wind turbines. So these points are created based on a 2D digitization or existing 2D data. and they are given the 3D dimension based on a triangular irregular network, a thin surface that as the altitudes of the public spaces. We're interested mostly in public spaces in the same city. So we have a set of observation points. These observation points is the same data that were later used in the CityEngine. This is just a demo of how this is created, the data that are imported in the CityEngine. This is the 2D environment in the ArcGIS Pro, and this 3D environment where we assign 3D information, which is customizable. In the specific example, a train track was selected, so the default height of 1.7, which is for the pedestrian, is not suitable. So you have a height that is more suitable for the window of the train. So the same thing can be examined in the building or in locations around the city related to locations that are on the ground or above the ground at specific heights. And then we calculate the visibility, which is a visibility based on the spot location of the observer and also on the spot location of the wind turbine. So this is the final step of uh, creating the visibility analysis. One can create multiple scenarios depending on which locations he examines and which are the targets. Here we select only 3 wind turbines from the whole dataset, which is a demo dataset. It's only 2025 wind turbines. The totality of the locations in this area, which is not the whole of Brussels, is 2079. So the calculations for the whole area is time consuming. It has been done. Here's just the demo as I told you. So also because you can select the density of the points and you can have visibility from very close points, you can have a very huge increase in the computational demand because the number of the points increases the calculation time. So I'll just let it finish here and show a bit of the results. This specific example, we have created the geospatial data with the results that we need for the specific scenario. So once loaded, one can see that there are only very few points with visibility for these 3 specific. This one is invisible from all these locations, and these 2 are visible from some locations. I won't let the video run through, so go to the next and see what the result we get from this. The result we get from this is these numbers, which are very large numbers. You see that from this location, one can see 250 wind turbines, and from this location, 237. And this wind turbine can be seen from 7,113 locations in the area. So it's a large number of calculations. So we have visibility, yes, no, and we have some distance in horizontal vertical angles geometry for this visibility. What we do not have, however, is the partial visibility, because the ArcGIS Pro in this tools can provide this two Boolean result, visible or not, and it does not compensate for the distance effect, although we can do that manually. But if we go to the actual shape of a small urban object, such as the wind turbine, we know that there can be obstacles. This is an example. that actually limit what is visible. So this portion is also a metric that is of interest, not just visible or not visible, which is a point measurement, but what part, how large a part of the wind turbine is visible, and what part also. This is the measurement based on the distance, which can be computed inside ArcGIS Pro, but in CityEngine we found a better solution. This is a view from my window, so you can see here two small towers. This is a church actually. So do I see the church or not? This is the question. Architectural also. And this is the building of Copernicus. So in the 3D depiction, we have these uh, buildings in the CityEngine, and we can run a full 3D analysis with the shapes. So we implemented the locations with a true model for the specific model of the wind turbines that we are examining. So this is the locations of the wind turbines as were determined from the wind energy analysis. This building, as you can see, is also enhanced. The building's geometry is enhanced with point cloud data from LIDAR from Aviair, and also there has been a terrestrial LIDAR on the roof, on the specific roof, and there are some other roofs that we have enhanced so that we can measure exactly the visibility from the points that we've seen before in the ArcGIS Pro. So we have a full 3D analysis, and we get the measurements that we can get from the CityEngine, which is the share in this specific field of view, which is customizable, and the value in terads, which is an absolute value, and it's not depending on the field of view. It's for its analysis. So this at the same time compensate for the geometry that the GIS Pro cannot at all calculate, and also compensates for the viewing distance because of the way that visibility is measured. So this is why a valuable addition to our analysis. The problem was that we could not save the data so easily so as to extract them and have these results of this visibility analysis into the ArcGIS Pro. So the process was automated because we have a lot of points and a lot of usage to analyze. And Python scripts were created in order to automate the process from the viewshed creation at the beginning. So the wind turbines and the points are introduced along with a 3D model of the city, the actual 3D model of the city, not with city grammar. So the viewshed creation is automated. The viewshed calculations and also changes for the field of view, distance or angles or anything. And the most important is the data export to return this data to ArcGIS Pro so that they can be incorporated on the measurements from the CityEngine, can be incorporated with the measurements from the visibility analysis in ArcGIS Pro and have a combined result. So this is a capture from the creation of the view sets, where these commands were used, the create view set for the creation, and this is for the changes that we might need to have used. The default field of view for the CityEngine is 60 degrees by 30 degrees, horizontally, vertically. But we can establish if we want a more focused view, 10 degrees by 12 degrees when we actually focusing on something to see in detail, or a scene view for 135 degrees by 120. So these commands are in scripts that you saw before that allow us to manipulate the viewshed, create it and manipulate it. And after that, there are the scripts from which we extract the data to the CSV file. So we get it's for each observer point, we get these parameters, which is the distance and the angles of view are more or less known maybe. But the most important is the last one, where we get the solid angle. And here you can see the export of the measurements in terads, and can be saved, and they are saved in the CSV file. And this CSV file is imported into ArcGIS. So here we have a 2D representation of the results. And this is the percentage of a specific field of view for each location, which is for the whole array of the wind turbines here. So the visibility is from this location to this wind turbines which are on high building. Okay, and you can see from which areas here it's totally invisible, so we have zeros. And from these areas we can have a gradual detection of how visible this array of wind turbines is. So this was the first attempt to use the CityEngine. It was very interesting, although we had some problems with running some commands. The environment was a bit heavy for the computer that was installed, but it was indispensable in the analysis that we wanted to make. And the results will be available from this project, which is called Wave Project, as you've seen here. Will be available on a website which is being set up now with the ArcGIS Online, and it will be online in a couple of months, maybe, or before Christmas. So this was the whole project team that worked for this project, and I was mostly involved in this part of the visibility analysis. So I thank you for your attention, and I'm open to questions, although I cannot claim that I'm an expert in CityEngine, as you will probably understand, but it was a very cool application for us and an interesting result.
Very nice, thank you. So yeah, let's open the floor to some questions. I see some clapping. I agree. Very
She does
nice.
not do that. Yeah.
um,
One last remark: the code, both the code of the ArcGIS Pro and the CityEngine Python will be available in GitHub after the end of the project. So there will be a link, and maybe some people will improve it also.
Very nice. Then I'll try to. I'm just checking constantly if there are some questions coming in. Yeah. So in general, I'm curious the results kind of, or this breakthrough which you described, basically, of just having kind of direct point to point, is it visible or not, towards to having this, let's say, percentage of how much visible is it. What's the impact of this breakthrough in the sense of kind of the accuracy? What does it translate to, this partial visibility? Or because I mean, there in the whole topic of visibility analysis, especially of wind turbines, that obviously also very often have this rotational effect, which together with certain light angles hitting the
Mhm.
blades in a certain angle will also give glaring effects constantly.
Yeah.
So is this one of the aspects regarding the partial visibility, or is that something that you would even potentially go further? Because I mean, you could consider, if the let's say, if you have some of the blades that have
Mhm.
a very specific orientation for the wind turbine, and it is actually rotating, and you know exactly the sun direction, you could technically even compute where you will have light flashes, right? So
Mhm.
you could go a lot further, but maybe you
Yeah.
can expand a little bit on the disadvantage of using CityEngine.
Actually, this ankle issue is solved within ArcGIS Pro because you have an azimuth for the viewing direction. So you know if the observer is looking at the wind turbine at the northeast direction, for example, you know exactly the degrees. So
Mhm.
based on the hour of the day and the height of the sun and specific location, you can have the calculations for glaring. The difficult part maybe is the shape of the wind turbine, because it's revolving. But you can have an approach on that with the results from the ArcGIS Pro. So in this respect, you don't need CityEngine. what CityEngine offers is that you can get false positives and false negatives in ArcGIS Pro, because the viewing point might actually be invisible, and you say that it's visible, or the opposite, so you get false positives and false negatives for some locations,
Mhm.
which depends on the size of the wind turbine, which is it is small, but it's not this small. So if half of it is occluded, then actually we can have false positives, negatives, and in the distances that are closer to the wind turbine, it's more important, because the portion that is visible is significantly more than if you are at 2 kilometers, where you have a very small image, a very small object in your view. So this is where when the CityEngine is contributing, because it eliminates this false negatives and positives and gives you a true number. And then you need more research in order to establish from which Sterrat number and above this matters, because you will have to take into account, as you said, the lighting, the colors,
Mhm.
the foreground,
Mhm.
the background. So the parameters are not few; they are not too many. And there is also the subjective interpretation of viewing wind turbine. I have people that telling me I wouldn't want to see them; it's annoying. And
Yeah.
someone told me if I see them, I want to see them rotating, so that I know that they are producing energy, so they're doing something good. So it's from the social psychological aspect, it's another research. And so we focused on the most objective and the quantitative aspects, so you can have the
Mhm.
basis for the other calculations once you have the other conclusions on how the colors affect the lighting and so on. All this that we discussed. And that is
I
if we proceed, because with the current technology, it seems that a lot of these locations are eliminated. So
Mhm.
uh, at this point, you might not have many locations eligible, but with a breakthrough in the technology and the exploitation of the wind, suddenly you might have a whole lot more locations available. So you have to have your research and your policy ready before, because some people will be asking for permits to install them. So you have to have something to tell them on whether they can and what are the restrictions.
yeah. No, that makes absolute sense. But so I do have another question. So you mentioned at the very beginning in one of the diagrams you mentioned urban winds, and now I mean Belgium is huge. There's but in kind of in the north in general there are let's say a lot of offshore wind farms. What's the or let's say in areas that are inhabited, like AKA cities, wind turbines in general, they produce a lot of noise, a lot of glare, and so on. What is the advantage, or let's say, what is the incentive specifically in Belgium or in Brussels to actually still try to install windmills in general in urban areas versus just say, hey, let's do farms that are out in the ocean?
Mhm. Yeah, yeah. Besides also being green technology, but you compare it with clean technology, so that's not an advantage in this case when you compare clean technologies. By having them inside the cities, it's more of a energy efficiency, because you do not have the grid to transport it, and the grid, we know very well that has a lot of losses. So it's local production, local consumption.
Look,
You
okay, yeah.
avoid part of the grid. This is one major advantage. There's a second one, which is also important. It's the resilience of the cities, because we've seen in situations where you have from natural catastrophes to wars, you can have factories damaged, which is an easy target in case of a war. And you have a whole city blackout. And in this case, you have at least the minimum energy to run the basics, to satisfy basic needs. So there is incentive, but there are also the problems that you mentioned, so they have to be dealt beforehand.
Mm, mm. Maybe a very political question. the whole war situation in Russia and Ukraine, would you say it had an impact on this tendency of local energy production, or this let's say a political push in the sense of let's try to make things a little bit more redundant? Would you say that's true, or is that just an assumption and maybe a coincidence that this is being researched at the moment?
I think resilience was an issue before the war. Maybe it
Mhm.
enhanced some people's attitude toward that, or politicians. I'm not sure about that, but the specific project was proposed in starting before the war, so this one was not affected. But I think resilience was mostly established in the people's mind, mostly because of the natural disasters that we have experienced in the various areas in the recent years because of climate change and so on, and maybe also just enhanced from the recent developments.
Yeah, yeah, yeah. Yeah, I would say this was fantastic. Thank you so much.
Thank you for
Uh,
the invitation.
you're welcome. Well, all right. Yeah, then I would say let's do just a very first quick break